Hi everyone. Thank you for joining us on Saturday evening. We have with us Dr. Monit Kapoor, who's the dean with Chitkara University Punjab campus, and today he would be talking to us about Kubernetes. And I will not take much of your time and hand over the virtual stage to him.
Thanks, Anamika, for having me. And a short introduction does help. Folks, today we are going to talk about few things about Kubernetes, and I've been told that the audience is largely um, from student community, and there are a few industry developers also who are there. So I'll be taking you through a ride around Kubernetes, and it's an open source container orchestration system that primarily hinges on the containerization capabilities of Docker, which is the most primary and industry accepted standardized tool, if I may say so, though it was not so a couple of years or maybe 3 years ago, but now the Docker project has really matured, which has led to much more action in the Kubernetes project over last 2 to 3 years, and hence Kubernetes has become an orchestration system of choice for containers and the container runtime environments. And without much ado, let me just jump to the next slide, which is about myself. Currently, I'm working at Chitkara University, Rajpura, which is in Punjab. It is near to Chandigarh, and I'm myself a professional with 25 years of work experience in a just industry as well as academia. My delve into technology, or my ride on the technology roller coaster, is around 13 to 14 years as on date. Uh, I'm an electrical engineering graduate by from my graduation, but after my masters, I've been into computer science and technology that we see a lot of these days today. And back in year 2009, that was a time when we were creating industry-oriented computer science programs, on various cutting technologies uh, like cloud and so I think I hit a glitch. Yeah, I'm still there. So then another thing is that I've myself trained on cloud and DevOps by received those trainings certifications from IBM ZBI Linux Foundation. And I work very closely with Reskill, and I'm a thorough advocate of all the open source technologies that we see these days. And this is the agenda for today's session, which is we are going to prime up for Kubernetes. In first few slides, I'll discuss about the architecture, and then we talk about some industry trends. I've got some number and data crunching for you, how this whole ecosystem of Kubernetes and containers it is faring, and then I'll make you walk through a step-by-step approach, small steps that you take when one wishes to launch machine learning workload on Azure Kubernetes services. Why I'm calling them as baby steps, I'll let you know at a right point in time, because I sit on boards of interviews of many companies as well as while hiring for academic positions, and we have seen that people are doing machine learning. People know containers, but I have seen very few people who know how to launch learning workloads on Kubernetes kind of a orchestration system using power of container tools. So I'll be taking you through that, and of course, later on we can have discussions. You can put in your comments, your thoughts on the chat. I'm looking at those. Okay, so here we begin. So the first thing that we need to focus upon is that why do we need Kubernetes? Inside containers, containers are completely isolated runtime environments, and they possess everything under the hood that is needed to run a service. And you can have replicas of services running, you can have replicas of containers running the similar services, or you can have different containers doing different tasks for you folks. uh, but yes, multiple services can run inside containers. Also, what challenge that throws to the people who are maintaining is that if we deploy more persons per service, obviously manpower cost goes up, which is not desirable at all. Then, with present times in the era of ubiquitous web, scaling them up is a real tough ask. And um, if something is running in production, how do we go on to modify that or update that? And also, reckless usage of cloud services can put a hole in the pocket of the people for whom you're working. And that is where I come from when I talk about how we see professionals doing it wrongly, or not correctly, what is the correct way according to us. And also, setting up services manually, that becomes a huge challenge, when it is about running container led service delivery. So from that standpoint, all these challenges were there before Kubernetes arrived on the horizon. And this is a little historical aspect. You might be already knowing that, but to put things into perspective, I guess these couple of slides that I'm right now showing, these are important. So I brought them in for you for your consumption. And if you see at all the challenges that are there, they lead to some kind of economical challenge. And if there is an economical challenge while running a technology adoption becomes slightly difficult, because organizations are not there for charity. So so one has to look at them very carefully. So then comes in that what then exactly Kubernetes is. So Kubernetes is a container orchestration tool, as I mentioned in the starting slide, and it is a open source project which was initially created by Google, and then it was donated to CNCF, which has now further open sourced it, and now it is available for all of us to create a fork out of it. We can customize it as per our own needs. Many organizations are doing that. And it is a portable platform. In other words, you can deploy it on variety of host operating systems. And what it does for the developer community is that whatsoever workload you wish to introduce inside a container, uh, and based on the traffic on your service, uh, the ask on the infra, it can go up and down. So there are a lot of swing that can happen. And what Kubernetes helps a developer to do is that it automates the scaling aspect. So manual scaling is given a go by, and you can automate it. You can through this tool, you can create replicas of existing services. You can launch more containers on the go, and you can pretty much orchestrate the way they are consuming the resource, for a better user acceptability and for a better service management. And what Kubernetes essentially does is that it groups the containers into logical units that we call as namespaces. And under the hood, Kubernetes is written in Go programming language, and that is precisely the reason that Go programming language skills have become particularly very important over a period of time, right? So this is some initial uh, giveaway about Kubernetes project and what it actually means. And primarily, it is a container orchestration tool where you can address the containers, and inside those containers, the services, a set of logical units. So the concept of microservices also becomes very very important, because microservices architecture is what you would refer to while building your applications, and all those microservices that you visualize as an ensemble that connect with each other to create a credible application. That is what you would be launching inside those containers, and to orchestrate that you would be utilizing the Kubernetes tool. The main features of Kubernetes are you can automate the scheduling. So, when to launch, when to stop, all of those things can be automated using Kubernetes. And self healing is one very, very important aspect of Kubernetes, in the sense that you can replace, you can restart the containers which are dead, and so the system is self healing, which gives a better user experience and a better service delivery. Also, all the rollouts and the rollbacks that you do as a developer day in day out, they can be automated. So, so whatever is the state of the containerized application, you can do a rollback, you can do a rollout from there, and Kubernetes is very very helpful in doing all of that. And as we talk about container tools, this concept of horizontal scaling and vertical scaling becomes very very important, in the sense that when we scale an application vertically, the monolith of the application keeps increasing like a big sized tower. But when it is about horizontal scaling, you can replicate the containers, uh, you can replicate the pods. So those replicas inside the Kubernetes, they help you to scale horizontally. And then therein comes in the load balancing aspect, based on the traffic that is hitting on each of the microservices on the overall platform that you're delivering, so that the microservice that needs more attention of the infra management aspect, that would be automatically addressed to by the load balancer that is built in the Kubernetes project. So Kubernetes can scale up, scale down the portions of your applications as per the requirement. And to further simplify things for you, initially the orchestration was led by Docker Swarm, which was not a very practical way, if you ask me, because it didn't have feature of auto scaling. Even the community that you see on the Docker Swarm is not very very helpful, and though it is quite easy to start a cluster, uh, but then the takeaway from Kubernetes is that the services that it provides, so scaling can happen, scaling can be done, but if the tool is not good enough, no point in doing the scaling for that. So that is our take. And also, uh, Docker Swarm was limited to Docker API's capability, whereas Kubernetes can overcome constraints of Docker and Docker API. And Docker Swarm does not have as much experience with the with production deployments at scale, whereas Kubernetes, it is being adopted by organizations precisely for the simple reason that deployment at scale is a few clicks away. So that is the reason that Kubernetes overtook Docker Swarm over last few years, and now you see not much adoption of Docker Swarm. Still, it is there in the market, but yeah, Kubernetes has gone many many notches above in terms of community support, auto scaling support, and the rollback rollout features that it provides. So it becomes a tool of choice when it comes to orchestration of the microservices or the containers. Next is about the architecture of Kubernetes, which is pretty simple to understand. Uh, as you can see in the control plane, so you have HCD, you're a controller manager, you got a scheduler, and you got a Cube API server. So you interface on the Cube API server, you know, by the kubectl tool, the command line tool, and HCD is the NoSQL database that supports the various database entities that are needed to support Kubernetes access, like the usernames, the network IDs, so on and so forth. And kubectl provides you the APIs via the Kube API server to interface with the HCD's component controllers and the schedulers. And from there, as you can see, we got pods. Inside those pods, we got container runtime environments that are deployed inside those pods, and the services are running inside the pods, and system services are there. Kubelet is there, and which is further taken care by the load balancer. The load balancer keeps on generating traffic based on the requirements of the end user, and it is almost seamless. So these are a few important terms which are needed to understand the Kubernetes architecture. And container runtime, when we talk about them, so container runtimes are like Docker runtime environment. So on top of that, containerized service would be launched, which will be further deployed into a pod of Kubernetes, and all these pods are for the replicas. They can be replicas, they can be individual pods, which are logical groupings of the services that are running. So you can have more than one service running inside a container, or you can have multi variety of containers that are running variety of services. These services can be anything under the hood. It can be database, it can be network management, it can be a microservice. It all depends on how you are integrating your application. Or it can be a machine learning workload. That is where we are headed to. Now, deployment in a Kubernetes cluster, you need to, this diagram will pretty much tell you how deployment is being done through the Kubernetes cluster services. So access the APIs using the app.yaml. YAML is yet another markup language, and you utilize the services of that to access the cluster services via the APIs, and then inside the worker nodes you deploy those images, where you can see P is the legend for pod and R is the replica. So whatsoever is there in the pod, you you create a replica of it and you keep on deploying them. So this is how deployment is done on the Kubernetes. I got a detailed chart for you later on how to deploy machine learning workloads that will connect with this diagram, and a little bit about how current and future state in enterprise is happening for Kubernetes. So if you Gen 1 is single cloud, Gen 2 is multi-cloud, and Gen 3 is hybrid multi-cloud. So if you see at this Gen 3 hybrid multi-cloud, which is the present times we live in, so Kubernetes has got built-in APIs, or you can have your customized APIs, and Kubernetes then further controls the container-led microservices deployments on any kind of a cloud using APIs. So you can pretty much connect with any kind of a cloud using Kubernetes, and Azure is also one of them, where AWS, Google Cloud, and even private clouds. So those kind of operabilities are possible when we are utilizing Kubernetes as a tool. And the recent trend, if you see, um, it is on upswing. So this marriage that I always say between Docker and Kubernetes, it has really taken off, and it is kind of eating up business of all other uh, operators or tools that are available in the market. And the chart on the right supports that claim, and you can see. where Azure is in in the percentage of container organizations running Kubernetes. So Azure is a 65%, whereas when it is about Google Cloud, Kubernetes obviously ubiquitous over there. But it all depends where you are deploying your application. So this is just to give you an idea where the current state of the whole container and orchestration market currently is. And now we're going to talk about how to deploy an ML workload on container cluster with Azure Kubernetes services. I purposely put in some in obvious abbreviations for you over here, like Azure K8s. You normally read it as AKS, but we're talking about Azure K8s and how to deploy a ML workload. Now, like I was talking to you at the top, so we were, speaking to a few of the candidates for a faculty position at one of the universities, and the person was working on real-time video streaming project. So he had been financed by government of India. He had a huge RAM available to him for generating those kind of for running those kind of workloads. But what primarily wrong the person was doing was that he was running the real-time video analytics services using a monolithic application and deploying it on the machine just because he had a compute power of 64 cores. So that doesn't mean that you should be utilizing all of that. You could have pretty much underutilized the system and given it off to somebody else who could have done some more task on the same system. But it was primarily utilizing the entire uh, nodes that were available to him without bothering to generating the machine learning workload in the fashion it is supposed to be, and without utilizing any microservices led architecture, which meant that the services that he was running, they were a plain monolithic applications like a 3 tier or a 4 tier application that you we used to do a couple of decades ago. And when we asked what was the bill steering up for the organization, and it was very huge, much more than we expected, and it was basically wastage of funds. So why I'm sharing this anecdote or story with you is that if you're deploying a machine learning workload and you're not utilizing containerization services, you're bound to put a strain on the infra because of the sheer demands of the machine learning workloads. And in the era of digital transformation, where companies are moving on to cloud, they obviously ask for a data-driven decisions for their day in day out operations, and for any kind of a data crunching, number crunching, we are utilizing artificial intelligence and the power of machine learning algorithms to infer correct insights from the data that the business and customers of those organizations are providing to the platform. So those machine learning tasks or the machine learning workloads that we are kind of working upon day in day out, they ought to be inside a container, and then they have to be managed through a cluster of containers, and for that you have to orchestrate. So hence this whole piece about deploying a machine learning workload on a container cluster with Azure Kubernetes services. So the common steps while we do this is we develop a model, we develop a model API, we prepare a Docker container for web services, and then we deploy it on Kubernetes. These are the common steps that you take while doing artificial intelligence or a machine learning task. So I've further bifurcated all of these steps, how to deploy on Kubernetes with kubectl. So I'm giving you a step-by-step approach today So the first thing, of course, is to develop a model. And how do we develop a model? We develop a model on a solitary machine, maybe a virtual machine, where we take all that infrastructure that we are, on which we are further going to deploy. So at the end, so we develop the model, and while developing the model, of course, there will be a training set of data, there will be a test set of data, and once our tests are validated, uh, the recall and the precision rates are as per our accepted standards, the model, once that it has been developed, then what we do is then we develop a model API and a create Flask app. Flask APIs are available on the Python, and plenty of Jupyter notebooks are available again on the open source. So we create model APIs and we create Flask application. And once we have created the Flask application, that is the time when we build a container image of the model with the model and model API in the Flask app. So we create an image and then we test the image locally on our local runtime environments without pushing it to the Docker Hub. And if the tests are okay and as per the standards that we have initially fixed for the team, we push the image to the Docker Hub. Once this image has been pushed to the Docker Hub, we provision the Kubernetes cluster. And after provisioning the Kubernetes cluster, what we do is we connect to the Kubernetes with the kubectl. And finally, we deploy the application with the manifest. So uh, this is a flowchart that connects two parts for you. One is how to develop a model and creating a machine learning application. That is the first part. And second one is where you already know how to deploy any application onto the Kubernetes. So the two flowcharts have been conjoined to give a clear-cut picture what are the steps that as per us are to be taken to deploy a application so that you can leverage the full power of the infrastructure you have at your disposal. This is one uh, picture that will give you a very clear cut idea how to deploy on Kubernetes with kubectl. So you got a Docker image on the Docker hub, and you simply pull it and you provide the input data and you request with the payload and you distribute the request to the pods. That is how you do. And the image or the model scoring function that is running inside the container environment inside a Flask application, which is further encapsulated inside a pod, and it is talking to the Kubernetes services through the HTTP mechanism, and the model is getting trained and tested. And once it has been tested and trained, so this is one simple way to do a machine learning application on Kubernetes cluster. But and this picture has been sourced from this repo, though it has been archived, but still this is from where if you're a newbie you should be beginning with, and later on you can go to what I'm showing you just now, which comes from the documentation of Azure Architecture. If you see input data, it has been given to the request with payload, where you launch uh, virtual machine with Microsoft Data Science Services, and you authenticate and distribute the request to the pods, which are available in the Azure Machine Learning Ensemble, and uh, model scoring script is created like a web service inside a Flask API again, which is running inside a pod, which has been deployed inside a container and then running inside a pod. And Azure Kubernetes services, they they are also available in the same logical grouping. And Docker image are available inside the Azure Container Registry. So you so so whatsoever application that you have created as a model, that will be transferred as an image to the Docker image, and it will simply pass to the pod. So you deploy it like this when you're doing machine learning applications. So with this mechanism, you can leverage all the power of Kubernetes, which is available to you, uh, and this will definitely be cost beneficial for you, and it will save a lot of effort for you, for the simple reason that if the data stream it becomes bigger, or you want to enhance your data streams uh, from the ingestion that you're doing from various sources that you have, to further make your system, make your model more reliable, more trustworthy. So all of those demands will be handled with the help of the load balancer mechanism that is available inside the Kubernetes, and uh, it is it is it is pretty much prescribed for cutting costs. So this is about how to you know put a machine learning workload using the Azure machine learning uh, services that are available. You create those images, put inside a Docker image, and then you deploy it on a container, which is running inside a pod, which is taken over by Kubernetes orchestration tool, and the data you can now stream to test your application, to run your application, and even to provide insights back to the user, which are ready now with the input data. So this gives a faster and a more economical solution to your day-to-day machine learning workloads. And if you will visit any of the research articles that are being published, very few talk about this whole mechanism. They are doing in their own. Of course, you will see a lot of research when it comes to development of machine learning algorithms and development of machine learning workloads. But uh, but when it comes to orchestration part, which is precisely the ML ops of the machine learning, very little noise is being made by the research community, and you will see mostly it happening that in the practice. For example, Azure is coming up with this practice, and it is giving you a complete rundown on the on how to do a real-time machine learning model, where this model is of course scoring something. It is scoring counts of various instances that are pre-trained in the model. So you can pretty much use the same framework to deploy your own machine learning model that you are working upon, because the tasks that are needed in the machine learning, the tasks that are being done by a machine learning algorithm, that will depend from case to case. Like whether you're deploying machine learning to do image classification, or you're trying to detect edges on some medical images, or whatsoever is the work that you're trying to do, or maybe you are doing some machine learning on the satellite imagery. It all depends what kind of a task you do. But if you deploy it using this whole mechanism, you will definitely saving a lot in terms of the cost that you're going to incur on the machine learning workload that you're generating for your organization, and not the way that I found few of the people whom we were interviewing at various places doing it. They were doing sheer heresy, and don't indulge in that. So this is about the machine learning workload and how to deploy it. And I'm open to discussions. So if there are any questions there on the chat. So I have Varun Bansal. So what are some of the resources you would suggest to learn K8s? Varun, there are plenty of open source port, even the Kubernetes project itself is open source. So you just visit GitHub, you'll find plenty of stuff to begin with. And why to learn from anywhere other than the Linux Foundation and the CNCF? So there is a free introductory course on Kubernetes over there. So you can pretty much refer to that. And there are a few paid courses also which are available on various edtech platforms. I won't be naming any one of them. You can take any one of those. I hope that satisfies your first query. And the second one is, what will you suggest? What to learn K8s first, or one should directly learn AK? Varun, First thing that you need to learn is Docker as a tool and how to deploy. Your learning journey should begin from launching a simple app, converting a simple three-tier application into a microservices-led application, where you deploy each of the microservice that stitches your application, and you stitch your application based on those microservices, and you deploy all those microservices inside the container. Once you successfully do that, then you are in a position to launch pods and everything. Once that is done, then next step is obviously you can try your hands at complex architectures and complex solutions. Okay, so any more questions? I'm waiting for the question on the comments. And
I don't see any questions coming in.
yeah, actually, I can see only two by Varun
Yeah,
Bansal.
Varun. Yeah,
Yes.
that's what I can see. So I don't think we have more questions.
So that's it. Thank you, Anamika, for having
Thank
me over here. In
thank
case
you
there are no
very
further
much for your
questions,
time on a Saturday. Thank you very much, sir.
bye then.
Bye.
Thank you for listening me out. Bye bye.